Okay, here's the example that was given. We've got the function f of x is equal to the absolute value of x plus 2. When you graph that, it looks like this. It looks like the graph of the absolute value of x, but shifted 2 to the left. And it tells us that it's defined piecewise in this way. Well, let's examine exactly what this notation means. Okay, so look. We think about it as it's actually two lines. This line here, which if it went on forever, it would keep going, but it stops here. And then this line here, which again would continue to go this way infinitely, but it starts here and keeps going. So in other words, when x is less than 2, right, for this region of the x-axis, we're using this line. And then at this breaking point, from 2 on negative 2, sorry, from negative 2 on, we're using a different line. So it's like in piece. So this line for a while, then stop here, and then start using this line. Okay, so from x is less than negative 2, we're using the function, or the line, negative x minus 2. In other words, this line has a slope of negative 1, right? And has a y-intercept, or would, of negative 2. So that's the equation for this line. But then once we get after negative 2, we're going to use the line x plus 2. So it has a slope of 1, and it has a y-intercept of 2. So less than 2, negative 2, we're using this. Greater than or equal to negative 2, we're using this. So in total, the function can be defined as negative x minus 2 when x is less than negative 2, or x plus 2 when x is greater than or equal to negative 2. And again, this equal to we could have put up here. It's arbitrary which one you want to say is on to. So for f of x is equal to the absolute value of x minus 3, first of all, we want to get a feel for what does that look like. And here's what it looks like. It's just shifted down 3. So here it is. So again, we're using two different lines. This line until we get to here, and then this line after that. So where is that? That's at x is equal to 0. So look, when x is less than 0, going this way, we're going to use this line. And the equation for that line is f of x is equal to negative x minus 3. It has a slope of negative 1 and a y-intercept of negative 3. After 0, we're going to use f of x is equal to a positive slope of 1 and a y-intercept of negative 3. So 1x minus 3. So all in all, we're going to define it like this. F of x is equal to two cases. It's going to be equal to negative x minus 3 when x is less than 0. Right? So when x value is less than 0, we're going to use this line. And when x is greater than or equal to 0, right, we're going to use that line. And again, we could have put the equal to on here.